Hello, what is going on? We are going to do this question 6. Last time I did this question, but I haven't had press the record button. I'm so sorry. No, sorry for me, man, not for you. All right, let's give it a go. All right. What is this question about? 3 mark, not too many marks here, but you've been given two triglycerides. Yeah, as you can see two triglyceride no triglyceride A and B. What is a triglyceride? Do you remember what triglyceride is? Which is a part which is made up of one glycerol and three fatty acid. That's what triglyceride is, which has got three ester bonds. You see that this is a one ester bond, another ester bond. Okay, these are the three ester bonds. Okay, every triglyceride has to have ester bonds. Now you know that triglyceride made up of glycerol part. This is the glycerol part, and this is the fatty acid part. Now, as you can see, some of these fatty acid part has got carbon-carbon double bonds. So, once what happens when there are carbon-carbon double bonds? Yeah, iodine or hydrogen can react with this carbon-carbon double bond. You should know that. Is that all good? All right. So, what's happening here? Okay, now uh, the question is, what is question is asking you? Okay, yeah, no, before we start looking at the question, all right, so this this fatty acid of the triglyceride A is a saturated fatty acid, isn't it? This one is unsaturated, mono unsaturated. There's one carbon carbon double bond, and this one is again a saturated fatty acid. So when there is a mono unsaturated fatty acid, if you are reacting with that with hydrogen or iodine, you know that, and we will have to end up spending hydrogen or iodine to to react with this carbon carbon double bonds, right? So one carbon carbon double bond means you need one molecules of iodine in this case, or hydrogen. So sorry about this stupid cough, I hate this. Anyways, uh, okay, now when you come to triglyceride B, oh, it's an interesting one. You have a one carbon carbon double bond. Now look at this one. This got 1 2 3. So it has got three carbon carbon double bond. And now let's look at the question. As 0.1 mole of sample of triglycerides was added to a test each sample. So if you have 0.1 mole of this, so it's what matters is the number of moles of carbon carbon double bond you are getting. You get 0.1 mole of carbon carbon double bonds, right, for the first one. So from the first one you get 0.1 carbon carbon double bond. Oh, this is ridiculous. Okay, that makes sense. All right. So however though, if you get this is A, if you get 0.1 mole of triglyceride B, right, you are taking what? If you take 0.1 mole of that, you will be taking 0. Carbon carbon double bond 0.1 times 3, 0.3 moles, right? Is that clear? Because every 1 mole of triglyceride, every 1 mole of that will have 3 carbon to carbon double bond. 3 moles of carbon to carbon double bond. Is that right? Okay. But if you take 0.1 mole of that, you will only get 0.1 mole of carbon carbon double bond, because 1 to 1 is the ratio. This one 1 to 3 is the ratio. So altogether, if you take 0.1 mole of A, 0.1 mole of B, you will be taking 0.4 moles of carbon carbon double bond. Then what is the question is asking you? You are reacting with bromine. So in other words, now you have 4 moles of carbon to carbon double bond, right? 4 moles of that means every carbon mole of carbon to carbon double bond requires 1 mole of bromine. Then since we have 4, you need 4 moles of Br2, right? Then again, sorry about that. Okay, but we got only 0.4 moles of this, therefore you need 0.4 moles of Br2. Okay, let me clean that up. I don't think I did it properly. No, I did the answer properly, but not the working is right. So in this case, you can write therefore number of moles of carbon-carbon double bond present is equal to 0.4 moles. Therefore, number of moles of bromine required is also 0.4 moles. That's simple, isn't it? Yeah? Do you find it simple? I mean, yeah, it is not that difficult. Man, not that difficult. All right. Let's do, name all the product formed when triglyceride A is hydrolyzed. Good one. Good one. All right. We'll spend a bit of time understanding how to hydrolyze this and how to identify the fatty acid part of this triglyceride. No, what I was meant to say, this triglyceride made up of a glycerol and 3 fatty acids, and we are trying to identify what these fatty acids are. In order to do that, you need to look at the data booklet, man. Data booklet. Is that clear? Yeah? Oh, data booklet. So we need to look at data booklet. Who is the legend? Huh? Sorry about that. Okay. Now, in order to do that, so what we do, we hydrolyze the fatty acid. No, hydrolyze the triglyceride. So how do you do the hydrolysis? Break the line, breaking the ester bond. After that, this side H, this side OH, this side H, this side OH, this side H, this side OH. You see that? Then let's try to identify the first fatty acid. This one has got carbon 16, 17, 18. C18 is a saturated one. Then C18, H36, O2. Simple. Then you can look at the data booklet and find out what that fatty acid is. C18, H36O2 is, this is stearic. Stearic. All right, we've done that. Then the next one. C 7, 8, 9, 10, 17, 18. C 18. All right. Now, how many carbon-carbon double bond? One carbon-carbon double bond. So 7, 8, 9, 10, 17, 18. So one carbon-carbon double bond means you take away 2 hydrogen. Okay, C18H34. C18H34O2. This is oleic. Oleic. All right. Then the last one. What is the last one? Okay, what's going on here? Okay. C14, 15, 16. 14, 15, 16. C16, C16. OH32O2 because it is a saturated fatty acid. 15, 16, 7, 15, 15, 16, 32, C16, H32, C16, H32O2 in linolololic. Linolololic. Is that right? No, I made a mistake there. C16, C16, H32 palmitic. Palmitic. That's it. All right, you can identify these fatty acids exactly the way I did. So that's going to be like what? Okay, you want to do it? Let's do it. C15, 15, 16. So C16, H32O2. Right. 15, 16. The next one. 7, 8, 9, 10, 17, 18. No, that's the same. We identify that. Okay, next one. The last one. We identify the last one. 4, 5, 6, 7, 8, 9, 10, 17, 18. C18. How many carbon-carbon double bonds you got? 2. 2 means 36 minus 4. 32. H32. O2. Then look at the data booklet and identify that. Alright, that's done. Okay. We have done that. Now, I'm planning to do another sack. Maybe today, maybe tomorrow. We have to do as many sacks as possible, man. Sacks as possible, yeah? What do you need to do? Wake up and You see, wake up and study. Then you become a legend. All right. See you soon. Okay. Bye.